Assalamualaikum and good day to all the examiners and everyone. First of all, my name is Muhammad Farhan Bin Razali and today I will glad to present my final year project with the title of Torrefaction of Palm Biomass with Limited Air Environment for Various Residence Times. Throughout this presentation, we will look into the 5 chapters of my research. Firstly, introduction. Secondly, literature review. Third, methodology, followed by result and discussion, and lastly, conclusion and future work. In my introduction, I will explain and describe 4 important points of my final year project, which are background study, problem statement, objective of my study, and finally, scopes of my study. Let's start with what is the meaning of torrefaction. Torrefaction is thermal process at specific temperature and times to convert biomass into coal-like product. Torrefaction normally conducted at a high temperature between 220 to 300 degrees Celsius. So let's see an example of torrefaction process by Muhammad Farhan. This is the image of raw palm kernel shell (PKS), one of the biomass from the oil palm. The raw PKS undergoes torrefaction process and here the torrefied product. So normally after the torrefaction, the biomass product will become darker as we can see here. So 300 degree is the darker than 275 degrees Celsius. So we can conclude that the higher torrefaction temperature, the darker the product will be. Now, let's see the problem statement of my study. The first problem of my study is the biomass characteristics are still not competitive if compared with coal. Coal has high moisture content, low calorific value, and low energy density. The second problem is the abundance of oil palm waste from oil palm plantation every year. According to Ais Yusof in 2019, oil palm plantation areas in Malaysia cover about 5.8 million hectares. The third problem, which is the most important part in this study, the usage of nitrogen supply during torrefaction become an additional cost. Therefore, the present study focused to eliminate the dependence on nitrogen supply. The main objective of my research is to evaluate the performance of palm biomass after torrefaction under limited air environment for various residence times. In this slide, I would like to emphasize my project scope. Firstly, the torrefaction is conducted with varied residence times of 30, 60, and 90 minutes. Second, the performance of torrefaction is tested under limited air environment. Next, torrefaction temperature is set constant at 300 degrees Celsius. And finally, the performance is evaluated in terms of both physical and combustion properties. Physical properties consist of appearance, mass yield, and energy yield, while combustion properties consist of calorific value, moisture, volatile, ash, and fixed carbon content. For my research, the main reference for conducting this project are all the literature I have read. Therefore, now I will point out all my findings in terms of these criteria, which are palm kernel shell (PKS), torrefaction process, and limited air environment. The first reference by Muhammad Abdul Aziz, the topic on torrefaction of oil palm biomass. From the table here, we can see that PKS has the highest lining content compared to other oil palm residue. From this, we know that PKS was the most difficult to decompose during torrefaction. This gives me an input on choosing PKS as my raw material. For second journal by Muhammad Farhan, I identify that energy yield of biocoal produced always higher than the mass yield. A study by Jafar and Ahmad in 2011. From this table, we can see that both energy and mass yield decrease as the time increase. The decrease in mass yield because of the decrease in moisture and volatile matter. There is large amount of mass loss at higher residence time due to the decomposition of the hemicellulose. Next study about torrefaction of pulp biomass briquette by Hasan Faizal. First, briquetting process of pulp biomass will be done followed by torrefaction in the reactor. So the upper diagram shows the briquette die set, while this diagram indicates the torrefaction reactor for the torrefaction process. In my study, I will implement this briquette technique to design a die set for torrefaction process under limited air environment. So next chapter is my methodology. I will explain the process of my study with flowchart, equipment and material, and the type of process that will be used in my study. This is the overall workflow of my study, starting with background study and literature review, then break into two parts, one in preparing the material for the study and the other one to develop the reactor or die set for the torrefaction process. Then I conduct torrefaction process with limited air environment. After that, I collect and analyze the data for this study, and lastly, I will make conclusion and recommendation for future study. This is the die set which will act as my reactor during torrefaction. The die set consists of piston, wall, bottom die set, thermocouple hole, and air passage. First, thermocouple will be inserted in the thermocouple hole. Then wall is placed on the bottom die set. After that, the sample is placed on the bottom die set followed by the piston. I will let the piston to close with the natural gravity pull. This is the schematic diagram of the setup for torrefaction process. The setup for this system consists of heater coiler, piston, wall, bottom die set, PKS sample, thermocouple, and temperature controller. For the thermocouple, I will put the thermocouple tips near the sample. This is the torrefaction setup for my study. For each experiment, 20 grams of PKS sample will be used. Torrefaction will be conducted with constant temperature of 300 degrees Celsius. The residence times varied from 30 minutes to 90 minutes. One of the parameters that will be determined in this study is physical properties. So this is calculation and equation for mass yield, while this is the equation for energy yield. So mass yield is the percentage of mass remain, while energy yield the percentage of increased energy. Another parameter that will be determined in this study is combustion properties. Combustion properties including calorific value CV and proximate analysis. For CV, the sample will be placed in the bomb calorimeter for about 25 minutes. For proximate analysis, the muffle furnace will be used. These are the standard for these properties. Now, let's take a look at result and discussion. I will discuss about preliminary data, conceptual design of the reactor, temperature profile, physical and combustion properties. I have gathered preliminary data for my study. I evaluate the properties of PKS in terms of calorific value, moisture content, volatile matter, ash content, and fixed carbon content. The moisture content of PKS in the present study is 10.51%. The value is reliable and meet the requirement for moisture content indicated by DIN 5171, which should be below 12%. The value of ash content is 13.91%, which is higher compared to the previous study by Muhammad Farhan and Yoshimitsu Yumura. However, the value obtained in this study are still acceptable. Now, this is the flow of the conceptual design of the reactor for the torrefaction process. The concept idea comes from the briquetting die set used in a study by Hasan Faizal. I implement the concept and make some modification based on the previous die set. I add a 0.3 mm of air passage on the bottom of die set. I also improve the weight of the piston. Therefore, the piston will close and compress towards sample with gravitational pull. This is the final prototype of the die set. This is the temperature profile of the torrefaction process under 30 minutes of residence times. The range of heating rate to achieve the desired torrefaction temperature is between 23.69 degrees Celsius per minute and 33.68 degrees Celsius per minute. By referring to this graph, the overall trend is higher when the torrefaction temperature is increased. Only small fluctuations occur for high temperature, as we can see here. Thus, it can be said that higher torrefaction temperature gives better capability in stabilizing to the desired temperature. In the present study, we choose 300 degrees Celsius for the constant temperature because the condition show a promising result. In physical properties, the mass yield decreases with the increasing of residence times due to the decomposition of hemicellulose during torrefaction. On the other hand, the energy yield slightly increases with the increasing of residence times. Next, for combustion properties. This graph of calorific value against residence times. All the calorific values from each condition are meet the standard requirement as stated by DIN 51731 for commercializing purpose. It is observed that a longer time taken for the torrefaction process results in higher calorific value. The main reason is the increase in carbon content as the residence time is increased. This is the approximate analysis for this study. As the residence time increase, ash and fixed carbon content also increase. This will be the effect of high calorific value of PKS when torrefied at higher residence time. The values of ash content is higher compared to previous study because there is a high portion of incombustible elements within the sample. Besides, volatile matter decrease with the increase in residence time. It is recognized that the trend of moisture, volatile, and ash contents of the torrefied PKS in the present study is similar to the result stated by Amin Jafar and Munir Ahmad. Let's take a look at the result from the previous study on the next slide. This is the result from Amin Jafar and Munir Ahmad. We can see here the moisture content and volatile matter increases while ash and fixed carbon content decreases with the increasing of residence time. It is the same trend found in this study. Therefore, the value in this study are found to be competitive for commercialize. Now, I would like to summarize this study. For physical properties, with the increasing time, mass yield decreases, meanwhile energy yield is slightly increasing. For combustion properties, all calorific values are fulfilled the requirement stated by DIN 51731. For approximate analysis, with the increasing of residence time, ash and fixed carbon content also increases. Higher ash content value observed due to the increase in portion of incombustible elements. It can be said that the torrefied PKS for various residence time were effectively produced in this study. Torrefaction could be done under a limited air environment. This improves technology in torrefaction process and subsequently eliminate the dependence on nitrogen gas supply during torrefaction process. Therefore, it will become much easier to convert biomass into a better fuel quality with affordable way. Now, I would suggest the future work that can be done. First, the torrefaction process should be done with other type of biomass samples such as empty fruit bunch and palm masicot fiber. This will recover the most compatible biomass for the current torrefaction technique. Second, the detailed ultimate analysis on the element available in the PKS sample such as carbon, oxygen, hydrogen, sulfur and nitrogen need to be done. These are some of my references I used throughout my research project. Here, the Gantt chart for my final year project. Now, I would like to thank Universiti Teknologi Malaysia for their cooperation and support for this project. Special thanks to my supervisor Dr. Mohd Faizal bin Hasan for his guidance, valuable advice, and inspiring encouragement throughout the process of the project. That's all from me. Thank you for your attention.